call the second presenter, Lai Jia. Okay, we have Miss Lai here from Ministry of Swinburne, Sarawak. So, Miss Lai, so I pass the floor to you.
Let us welcome our second speaker, Lai Jia.
Very good day, everyone. I'm Jia from Swinburne University of Technology, Sarawak. Today, I will share my current postgraduate research work on studying the CO2 adsorption on palm kernel shell PKS-derived activated carbon AC, prepared from a single-step thermal process integrating activation and surface modification process. So this project is under the supervision of Dr. Mu Lok Hei and Dr. Chiu Juan Ting from Swinburne, and also Professor Elena Ivanova from Army. The theme of this research will focus on the PKS-derived AC, concurrent activation and modification CAM process, and post-combustion CO2 adsorption. Today's presentation will cover on the research background, research introduction, project methodology, the impacts of research, Gantt chart that reflects the project work progress, and plans for work publication. So PKS is selected to use as the starting precursor in AC production because of its high availability from substantial amount of oil palm waste that generated after harvesting, replanting, and vegetable and crude oil production. The reuse and repurpose of PKS can reduce the waste disposal problems, the release of artisan odor, and air pollution caused by open waste burning. Apart from that, the characteristics of PKS such as high carbon, high leaching, low ash content, and significant volatile materials can assist to generate active surfaces and pore formation in its derived AC with high surface area and more porosity. Besides, its hard surface can prevent the carbon structure from melting during high temperature thermal heating. PKS-derived AC can produce through three types of activation processes, namely physical, chemical, or physiochemical activation. For physical activation, PKS is first carbonized to become carbon-enriched material named char, followed by activation with the presence of oxidizing gases to form AC. In chemical activation, PKS is impregnated in a chemical agent over a duration prior to a simultaneous carbonization and activation process. Physiochemical activation is a combination of physical and chemical activation, which PKS is first impregnated in a chemical agent, followed by gasification with oxidizing gas. To further enhance the surface chemistry of AC, it was modified by amine or metal functionalization. In amine functionalization, AC is treated in an amine-containing solution over a duration, and then it is dry at mild temperature to form modified AC. For metal functionalization, AC is treated in a metal-containing solution, followed by a high-temperature thermal heating. However, the existing subsequent chemical modification process requires high cost, has complex reactions in preparation, requires prolonged operative time, and additional steps for modification process. And recently, chemical activation using metal salt found potential to produce porous acid comprising metal functional groups with adsorptive properties. Therefore, a single step process that integrates activation and modification process was proposed in this project to produce AC. Another issue that urges the conduct of project is the high atmospheric CO2 concentration. Total 76% CO2 was contributed from direct human impact induced on deforestation, land clearing for agriculture, soil degradation, and fossil fuel and industrial processes. This causes the atmospheric CO2 concentration to increase to 417 ppm in August 2022, and leading the average land and ocean global temperature to increase by 0.9 degrees Celsius. Therefore, adsorption process on activated carbon was imposed to capture this high CO2 emission. So, there are two types of adsorption processes. There are two types of processes involved in adsorption. There are physical adsorption and chemical adsorption. Physical adsorption typically occurs when CO2 molecules make a physical interaction with the active sites on PKSdAC surface through a weak van der Waals forces, while chemical adsorption on the AC surface is occur through a spontaneous formation of a chemical bond between the CO2 molecules and the surface functional groups. This project will perform in two experimental stages. There are the synthesis of AC and CO2 adsorption on AC. First, PKS is divided into smaller particles and remove the sand and impurities from its surface before it is carbonized to become char. The char is then impregnated in an acid solution and then dry for metal salt and then dry to use for metal salt impregnation. After the impregnation, the metal salt impregnated PKS is dried at low temperature to remove the residual metal salt and then undergoes simultaneous activation and modification process to form AC. Then AC is washed and dried for product characterization. ICP-OIS is performed to determine the amount of present element in the AC. This analysis is to make sure the metal salt incorporation is done on the AC that will be responsible for the chemical adsorption of CO2. CO2 adsorption performance of the AC will perform using TPD, temperature program desorption testing. This research will help to explore an alternative process in producing AC using a simple, brief, uncomplicated, and more cost-effective process, and also helps the palm oil sector to explore the possibility to convert the oil palm waste into high value-added materials. The reuse and repurpose of this waste can reduce the air pollution caused by the waste disposal problems and the open waste burning, and it's at the same time its derived material can use in the application that purposes to mitigate the environmental pollution problems. Besides, studies from this research can inspire the students to improve their skills on synthesizing the AC with better performance. So this project will take about 6 months towards its completion. And one journal paper publication was planned to serve the project works. The TPD testing will be done externally by Ms. Iriani at UTM, University Technology Malaysia. So this is the references that cited in the slides and for the future study. So that's all from me. Thank you.
Thank you, Jalen, for your presentation. Now I would like to pass the session to Professor Lam to moderate the Q&A session.